Right.
All right. Well, good afternoon, everyone. This presentation is an overview of my capstone project. The focus is on mapping crime analysis for Clearfield City Police Department. In the next few minutes, I'll touch upon the data used in the project, the automation process, the visuals used by the police department, and the distribution of those maps. Now, I'd like to introduce myself. My name is David Garritson. I'm currently a student at the University of Arizona studying in the master's program for Geographic Information Systems Technology. I work for Motorola Solutions as a senior analyst in Geographic Information Systems, and I live in Syracuse, Utah, which is about 30 miles north of Salt Lake City. My family consists of one grandbaby and one on the way, 7 children, 2 dogs, and an amazing wife. For fun, I like to read and go for walks to clear my mind. Now, I have chosen Clearfield City's police department as the subject of my project. Why Clearfield? Well, Clearfield is close to my home. I live about a mile west of the city. Growing up, I attended high school in Clearfield, but most importantly, I've worked with the police department for over the last decade as a software vendor. What would a project be without data? Thank goodness for the Freedom of Information Act, which made this project possible. I made an official request from the city records department asking for information gathered by the Clearfield City Dispatch Center. Following the request, I waited several weeks to get the data. I must admit, after a while, I started to worry that the data would not be delivered in time. However, thanks to Nancy Dean, the records clerk, she provided the data that I needed. Now, to understand the data, it's important to know where it comes from. A dispatch center, when you call 911, for example, computer-aided dispatch software, or CAD, is used to take calls for service. And then from that CAD or computer-aided dispatch, a record management system software, or RMS, is used to store the calls for service. To utilize historical records, the data must be extracted from that record management system using a database query. And that's what we're seeing here is this visual is the data that was removed from that records management system. For the project, I used 3,200 records that covered the span of summer 2021. The data extracted from the record management system was printed as a comma separated value file, or a CSV file. As for the data itself, several attribute fields were provided for the project. They include incident number. It's a unique ID for each call for service. Date and time. Incident type, this would be like a citizen assist or a domestic violence call for service. The full address, the city. Now, the city would be more important for a sheriff's office with multiple municipalities. However, I used the city attribute field in this project for Clearfield City due to a desire for the setup to be more flexible, so it could be used for more than just the city. Now, preparing the map data, using that comma separated values file provided by Clearfield City, a new attribute table was created. This conversion was made so that the data could be used in ArcGIS Pro. Using both address point and street data, a locator was created within ArcGIS Pro. To understand the nature of a locator, locators take a snapshot of reference data, which is used to standardize addresses and search for locations. Then I used a geocoder, which utilizes that address locator and the new attribute table to create a vector address point layer. It is this map layer that represents the data stored in the RMS, or Records Management System software. Now, when I refer to automation, I refer to a process that can be run with a single click of a mouse, all the steps needed for a procedure combined into a single step. With GIS software, automation is offered and is beneficial. Some of those benefits include simplifying the process, saving time, avoiding mistakes, and having a visualization of the steps. For this project, modeling was used to automate the process of preparing and manipulating the law enforcement data into a map format. For those that haven't used modeling previously, I want to explain the model that you're seeing. The yellow rectangles are various geoprocessing tools, for example, a create feature tool or a summarize percent tool. The dark blue ovals represent input data for those geoprocessing tools. The light blue ovals indicate that a process has completed for a geoprocessing tool. The green ovals are output data. However, in some situations, output data is also used by geoprocessing tools, and in this situation is used as input for the next geoprocessing tool. The connectors include a dotted arrow, which is used as a precondition, meaning the geoprocessing tool must run before the next tool. The solid arrow is a connector from input to geoprocessing tool, and then from geoprocessing tool to output. This model creates, populates, and outputs data as a polygon vector layer. During the process, it takes a CSV or comma separated values file from a current time frame and a past time frame. And then with a locator for Clearfield City, it geocodes law enforcement data. Then using the new feature class for current and past time frames, as well as a zone polygon, the data is spatially evaluated, determining a plus or minus percent value for calls of service for a given area in the city. Now, providing visualization of calls for service is critical for law enforcement. This is where maps come into play. These maps were created with the user in mind, providing the data to improve policing. These visualizations allow a user to determine the meaning of their maps. The first map we want to look at is a hotspot map. These are effective and easy interpreted. These maps are a representation of the grouping of calls for service. When working with dispatch centers and law enforcement agencies, hotspot maps are the most requested. With these maps, after data is geocoded, the symbology is added. This map is a representation of point distribution. Symbology draws point features according to their relative density. What does 80-20 mean? It means 80% of calls for service are in 20% of locations, or you can think of it as 20% of individuals make up 80% of calls for service. This map will help law enforcement to use a focused strategy and prioritize resources so that law enforcement agencies can make the most impact. This map assists in making information or informed staffing decisions. Now let me refer back to the model. The automated process that was shown previously is the foundation of this map. A comparison map will allow data to be measured by type of calls for service and allow a comparison of two time periods. This map provides a plus minus percent of change between time frames. Used with other maps, it provides a measurement for success. Now, depending on the audience, the map presentation will be different, whether it's a sergeant who is evaluating the calls for service in their patrol areas, possibly the police chief making personnel staffing decisions, or the dispatch center presenting to the city council. How the maps are delivered will differ depending on the audience. The presentation methods may vary as well, whether it's a large map printed on a design jet printer or an online map accessible from your PC or a smartphone. The only limitation is the imagination of those who desire the maps. Now, what you see here is an interactive pin map using Dashboard. Dashboards enable users to convey information by presenting location-based analytics using intuitive and interactive data visualizations. They assist in identifying instant numbers and associated call types, date of occurrence, and addresses. Also, it allows for a map user to target neighborhoods or individual addresses by identifying calls for service. With an interactive map, a user can analyze an exact location and gather information about like calls for service. Another method is using Experience Builder to present user-desired maps. Experience Builder allows data to be transformed into a web app by simply dragging and dropping and choosing the maps that are needed. With online tools, it is possible to update and provide maps to individuals that need them most. Now, in conclusion and as an overview, I covered law enforcement data is extracted from a record management system software that they use, the police department uses. Automation can be used in the form of modeling, which will simplify the process, save time, and avoid mistakes. And various types of maps provide answers to different questions. And then displaying results will vary depending on needs of the public safety agency. Thank you for taking time to listen to my presentation. Are there any questions?